We will show that time runs equally in all systems of reference, and that time dilation is an error of interpretation. We will deal with the transformation of coordinate between a stationary observer whose reference system we call the reference system of the station with coordinate x and t, and a traveling train at speed v passing in front of the station with coordinate x prime and t prime. Before using a Lorentz equation, we will make a change of variable that are seen in the figure. The inverse of the relativistic factor goes from 0 to 1 as cosinus alpha. Then, by inspection, we see that the velocity v is equal to c sinus alpha. We will calculate the evolution of the coordinate x and t prime for a train passenger. X is the distance from the station and t prime is the clock in the origin of coordinate of the train, which for t equals 0 coincided with the origin of the stationary system. After some time has passed, he has traveled x equal vt, and the lecture of his clock is, using Lorentz equation, t prime equal t divided by the relativistic factor, t divided gamma. Summarizing, we have put the inverse of the relativistic factor as cosinus alpha, and then v is equal to c sinus alpha. We see that the evolution on time of these two coordinates x and d prime may be written as c dt sinus alpha and c dt cosinus alpha, and this then the square of this variation are equal for all system of reference and is equal to c square dt square, and is not dependent on the velocity or the angle alpha. The evolution on time is dictated by the vector c. The conveyor to the future. This vector transports the traveler at distance x equal vt and advance the time in this point as t prime equal t cosinus alpha. In the orthodox interpretation, dx is not considered as part of the advance toward the future. Only t prime smaller than t is taken into account due to what is known as time dilation, thus assuming that time passes differently in the traveling system. But this dilation is not objective of the place where it occurs. It is observed differently depending on the system from which it is seen. This is not acceptable to our simple intelligence. Let's see the figure. At t equals 0, the origin of coordinate of the two systems coincide. After a time t, the stationary system has not moved, and only time ct has advanced. In the train, time has also advanced by the same amount ct, but from the station, the advance is broken down into two components. Ct sinus alpha has been used to advance in the spatial axis c sinus alpha t, and the other component has advanced the clock t prime equal t cosinus alpha. In the direction of the future of the stationary system, it is a shorter time because time is viewed from a certain angle. It is not due to a dilation. It is as if one were to look at the speed of a car forming a certain angle, one would see a speed that depends on the angle in which you look. If we see it from behind, we will see it as stopped. If a fixed observer on the train analyzes this situation, he will see that the time on the train runs straight toward his future, while the evolution in this station seen from the train is what breaks down into a component that gives the speed of the station, and the component that advances time in the direction of the future of the train. This component is the one that would be interpreted with the dilation of time. We have also included a figure that explains the twin paradox. Also, the sum of the length of the red line is equal to the length of the black one. The projection in the future of the station is smaller. For this reason, we see that the twin that has the lifeline in red is younger. We apologize for the poorly spoken English. Now we will stop here waiting to improve the videos in later videos. Thank you. Goodbye.